I'm going to present the solutions to homework number 2. In problem number 7, we have two functions, f of x given by 2 over x minus 3, g of x given by 1 over x plus 2, and we are going to add them. Adding functions is straightforward. We simply need to add their pieces, or their definitions. I think it's important when adding, subtracting, multiplying, or dividing functions, you write each function in parentheses. Since we're adding this entire function plus this entire function. In this example, it won't make a difference, but in many examples it does, especially if the sign between the two functions is subtraction and you need to make sure you distribute it. Okay, now we need to get these two fractions to have a common denominator. So I'm going to multiply the first fraction by x plus 2 over x plus 2. And then I'm going to add the second one by x minus 3 over x minus 3. So notice multiplying a value by x plus 2 over x plus 2 is essentially multiplying it by 1. So we haven't changed this value, nor have we changed this value because we're multiplying it by essentially 1. This is the same way you get common denominators when dealing with numeric fractions. We just happen to be dealing with functional fractions at this point. So multiplying the numerators, we have 2 times x plus 2 over x minus 3 times x plus 2. That's the first fraction, and to that we'll be adding 1 times x minus 3 over x plus 2 times x minus 3. And now you notice that we have a common denominator, x minus 3 times x plus 2, x minus 3 times x plus 2. So now we can add these two fractions keeping the same common denominator. Once again, it's important to remember that this is how you deal with fractions. So it's nothing new. So multiplying out the numerator of the first one, we have 2x plus 4. And then we're adding to that the second one, which is just x minus 3. And now we have the common denominator. Now once again, I don't need these parentheses here, but it often helps, especially when dealing with functions, to make sure you distribute the sign properly. If this was a negative, we would have a problem. And now continuing, we can just simplify the numerator, so that's 2x plus x, which is 3x, 4 minus 3, which is 1, and now we have x, and now we have the denominator. And feel free to multiply out the denominator if you like, but this is a sufficient answer here. In problem 12, we are once again adding these functions, f of x plus g of x, which is x plus 6 over x minus 6. Once again, being careful with the parentheses, plus x minus 6 over x plus 6. Now before we add these, just like when dealing with fractions, we need a common denominator. So I'm going to multiply the left fraction by x plus 6 over x plus 6. And then to that I'm going to add the next fraction when multiplied by x minus 6 over x minus 6. All right. Now all we need to do is clean this up. And we have x plus 6 squared in the numerator of the first one over x plus 6 times x minus 6. And to that we'll be adding, in the numerator of the second fraction, x minus 6 squared over x plus 6 times x minus 6. Now we have the same denominator, so we can combine those together. And we can multiply out the numerators to simplify them. So x plus 6 squared is x squared plus 12x plus 36. And x minus 6 squared is, so don't forget be careful with the parentheses. X minus 6 squared is x squared minus 12x plus 36. And now we just simply need to simplify this. And we get 2x squared plus 36 and 36 is 72 all over x plus 6 times x minus 6. And that completes our problem. For the next three problems, we are going to be combining these functions, f of x, g of x, and h of x. We'll start with 13, which is f of x minus g of x. So we'll take the function f of x and subtract from it the function g of x, which will be x over x minus 2, that's f of x, and from it we need to subtract g of x, which is 5 minus x over 5 plus x. Notice I'm using parentheses around each function. That's because this entire function needs to be subtracted from this entire function, and here it makes a big difference because this negative sign has to be distributed properly while combining these functions. Alright, so let's go ahead and distribute the negative sign and get started. Now when dealing with fractions, we can distribute the negative sign to either the top or the bottom, so I'm going to put it on the top. And put a plus in between the two, and I can get rid of the parentheses. Before going much farther, let's clean this up a little bit. Specifically, I'll clean up the second fraction. Distributing the negative sign, I get this. And now I'm ready to continue. So the next thing we need to do is find a common denominator for our two fractions. I'll multiply the first one by 5 plus x over 5 plus x. And I'll multiply the second one by x minus 2 over x minus 2. Now I'm ready to set this up as a common denominator of x minus 2 times 5 plus x. And let's clean up the numerator. I'm going to take this x and multiply it by this 5 plus x to give me 5x plus x squared. And similarly, I'm going to multiply this 5 plus x times this x minus 2. This is a lot to do at the moment, so I'm going to leave it for the next step, just writing minus 5 plus x times x minus 2. This is a nice way to save yourselves too many moves in one step. I'm just writing this out like this, and I'll multiply it out in the next step. Alright, cleaning this up, I have 5x plus x squared, and multiplying the second 2 out, I have negative 5 times x, which is minus 5x. Minus 5 times minus 2 is positive 10. Positive x times x is plus x squared. And x times minus 2 is minus 2x. And this is all over x minus 2 times 5 plus x. Continuing the cleanup process, I have 5x plus x squared plus, now combining the minus 5x and the minus 2x, minus 7x plus 10 plus x squared. All over the denominator, x minus 2 times 5 plus x. And finally, I'm ready to combine the numerators together, and I'll start by combining my x's. So I'll have 5x minus 7x, which is minus 2x. Next, I'll put together my x squared. So x squared plus x squared is 2x squared. And finally, I'll put together, or I'll leave my plus 10. And I'll have x minus 2 times 5 plus x. And while I'm at it, I'll go ahead and write my numerator in standard form. And that finishes up this problem. For 15, we're going to be multiplying f of x by g of x. And f of x is x over x plus 2, x minus 2, excuse me, times that by g of x, which is 5 minus x over 5 plus x. Now this is going to be easier than subtracting or adding these two functions, because just as when dealing with fractions, multiplying fractions is typically easier. So we simply have to multiply the numerators and the denominators. Just like when multiplying fractions, there's no need to get a common denominator. And multiplying this out, we have 5x minus x squared over x squared plus 3x minus 10. And we're done with this problem. For 17, we're going to be taking f of x and dividing it by g of x, which is x over x minus 2, all divided by 5 minus x over 5 plus x. And this works the same as when dividing two fractions. You're going to multiply by the reciprocal. So this is x over x minus 2. And we're going to multiply that by 5 plus x over 5 minus x. Notice I flip the denominator and I change the division to multiplication. Now this is just like last problem. All I have to do is carry out the multiplication. So the numerator gives us 5x plus x squared, and the denominator is x minus 2 times 5 minus x, which gives us in the numerator 5x plus x squared over x minus x squared plus 7x minus 10. And that's our answer. For the next two problems, we're going to need f of x and g of x, and we're going to be composing them in different ways. So to compose a function, I like to start by writing the outside function, which in this case is f of x. But instead of writing the x values, I like to leave an open parentheses where the x used to be so that I can fill in the g of x function. So I like to write the f of x, but where the x used to be, which is here, instead I'll fill that in with the g of x function, because that's the inside function, giving me x over 1 minus x all raised to the 6th power. Now there's different ways to rewrite this, but none of them is much simpler than what we have, so we'll leave it at that. Now, to do 26, we have the composition but in reverse order. The inside function is the f and the outside function is the g. Let's look at what these look like when put next to each other. So, as before, I like to start by writing the outside function, leaving a big open parentheses where the x's used to be. So I'll have a x over 1 minus x. Notice, rather than writing x, I leave a big open spot so that I can fill in the entire f of x function. And this leaves me with x to the 6th over 1 minus x to the 6th. And if we like, we can clean this up, and this equals x to the 6th over 1 minus x to the 6th. Now compare this to our previous problem, which, if I clean it up a little bit, looks like x to the 6th over 1 minus x to the 6th, which is a very different answer than our second one. This is 1 minus x multiplied by itself 6 times, and this is 1 minus x multiplied by itself 6 times. So composition looks different depending on which function is on the inside. Moving on to section 4, we're going to use the quadratic formula to find the zeros of the function here. We need to recall what the quadratic formula is before getting started. When given a function of the form f of x equals ax squared plus bx plus c, where the a and the b and the c stand for constants, much like there is a 2, a negative 7, and a 6 here, then the quadratic formula says the x's should equal negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So, in our problem, we can identify the a as 2, the b as minus 7, and the c as 6. A, b, c. Make sure that negative 7 stays attached to the make sure that negative sign stays attached to the 7. And now we simply need to fill in the formula, giving us negative b plus or minus square root of b squared, so that's 49, minus 4 times a, which is 2, times c, which is 6, all divided by 2a, which is 2 times 2, because a is 2. And now we just simply have to simplify this. So negative times negative 7 is 7 plus or minus square root of 49 minus 48 all over 4. Now it's simply a matter of cleaning this up a little bit. And we have 7 plus or minus 49 minus 48, and square root of 48, or square root of 1 is 1, and we have a 4 in the denominator. Now this actually gives us two answers because of the plus or minus, so we really have 7 plus 1 over 4 is x, and we also have x equals 7 minus 1 over 4. This plus corresponds to this plus, and this minus corresponds to this minus. So, this gives us 8 over 4, which equals 2 as one of our x's, and 6 over 4, which equals 3 halves as our other x. In problem 17, we want to factor the polynomial 3x squared plus 12x plus 12. first thing to notice is that each of the terms, the 3x squared, the 12x, and the 12, are all divisible by 3. So we should first start by factoring out a 3, which should leave us with an x squared inside plus 4x plus 4. And now we need to factor the x squared plus 4x plus 4 if it's possible. So we should end up with something like 3, and if everything goes according to plan, we should have a factor on the inside. We need an x here and an x here, so that when we multiply the two together we get our x squared. And we need to place a number here and a number here that multiply to be 4, but also add to be 4, which makes it plus 2 and plus 2. And we're done. Moving on to 21, we're once again going to factor this and notice that each of the terms is both divisible by x. So we can factor out x from both terms. And then we must have a 3 on the inside minus an x. And notice this is a linear equation, so it does not factor anymore. So we're done. In problem 25, we want to find the points of intersection of these two functions. The first one, y equals 2x minus 5x minus 6, and the second function, y equals 3x plus 4. To find the points of intersection, or at least to find the x values of the points of intersection, we set the two equations equal to each other. So we have 2x squared minus 5x minus 6 should equal y, which should also equal 3x plus 4. That's because 2x minus 5x minus 6 equals y, but also y equals 3x plus 4. So we have 2x minus 5x minus 6 equals 3x plus 4. Now all we have to do is solve for what x values make this true. So we're solving the equation, and now we can remove the y value and just look at the two leftmost side and the rightmost side. And we want to solve this equation. And this is simply a matter of getting all the x's to one side and all the constants to the same side and treating it like a quadratic equation. So we have 2x squared minus 8x minus 10, and this should equal 0. Notice I moved the 3x over to the other side by subtracting 3x from both sides, which gave me 5x minus 3x, which is minus 8x, and I subtracted 4 from both sides, giving me minus 6x minus 4x is minus 10. Excuse me, minus 6 minus 4 is minus 10. And now all I have to do is find what x values make this quadratic equation true. And there's multiple ways to go about this, but we're essentially solving this, and you can use factoring or quadratic equation or completing the square as you like. I'm going to notice that there's a 2 that divides this term, and a 2 that divides this term, and a 2 that divides this term. So I'm going to factor the left to be 2 times the quantity x squared minus 4x minus 5, and that should all equal 0. And this is nice because I can now divide both of these sides by 2. When I divide this side by 2, the 2 will disappear, and when I divide this side by 2, I'll just end up with a 0 there. So I've got x squared minus 4x minus 5 equals 0. And now I continue factoring, and if everything works out, I should have something of this form on the left-hand side with an x here and an x here to guarantee I get the x squared. Now I'm looking for something that multiplies to be 5 and that adds to be 4. So it looks like I should have a 5 and a 1. And now it's just a question of deciding which signs to put with them. Plus 1 minus 5. And now I have x plus 1 times x minus 5 equals 0, which means either x plus 1 is 0 or x minus 5 is 0, because two things multiplied to be 0 means one of them in fact is 0. So I have x plus 1 equals 0, or x minus 5 equals 0, which gives me x equals minus 1 or x equals 5. Now the question asks for the points of intersection, and we only have the x values of the points. So I must take these x values and put them back in the original function, which is here. So I can choose which of the two functions to plug these x values back into, because they should both should output the same y value. So because it's easier, I'm going to plug the x values into the second function. And for my first point, which corresponds to the -1 value, plugging the -1 into either function, I have 1. I chose to plug it into here, so -1 times 3 is -3 plus 4 is 1. And now plugging the 5 into either of the two functions, I get the corresponding y value 19. And we have answered the question. These are the 2 points of intersection. If you like, it's worth graphing both of the two functions so that you can see that they do in fact intersect at 2 places. For problem 35, we're going to be solving this equation, and there's multiple ways to solve equations like this. I'm going to go ahead and clear the denominator by multiplying both sides of the equation by x plus 4. Once again, there's other ways to approach the problem, but I would rather not have a fraction. So I'm going to multiply by the greatest common or the least common denominator on both sides. And I really should have a parentheses here. All right, and now we're ready to multiply this out. So the left-hand side will be x times x plus 4 plus 14 times x plus 4 over x plus 4, which will cancel nicely, which was why I multiplied both sides by x plus 4. And this should equal 5x plus 20. So I'm left with, on the left, x squared plus 4x plus 14, and on the left-hand side, 5x plus 20. And now we need to get everything to one side so that we can solve this as a quadratic equation. So this gives me x squared minus x minus 6 should equal 0. This is because if I subtract 5x from both sides, I'll have 4x minus 5x, which is minus x. If I subtract 20 from both sides, I'll have 14 minus 20, which is minus 6, and gives me this equation. And now, hopefully we can factor this to find a solution. If everything works out right, we should have an x here and an x here. I'm looking for two numbers which multiply to be 6, but multiply to be -6, but add to be -1. 2 and 3 seem to fit the bill. We'll need -3 and +2. So, this gives us x either equals -2 or x equals 3. Now, while it seems that we're done, we have to check one more thing. We have to check that these are actually solutions to our original equations, which means they must be in the domain, or we must be able to plug them into our original equation. So let's go ahead and check that. Looking at our original equation, we'll simply plug in our values and see if everything works out. So we'll start by plugging in the -2, and if it makes this true, things will be good. So we're looking at -2 plus 14 over -2 plus 4. That's plugging into the left-hand side, which equals -2 plus 14 over 2 which equals minus 2 plus 7, which equals 5, and we have a solution here with the minus 2. Next, we'll check the 3. So we'll have 3 plus 14 over 3 plus 4, which is 3 plus 14 over 7, which is 3 plus 2, which equals 5, and we have the other solution. This brings us to the end of homework 2.